we can factorize this form in this form. So a times bracket x plus a number, x plus another number, or x plus another number there. Okay. The shape of this graph would look like this if a is positive. Okay, and it would look like that if a is minus, a is negative, a is less than 0. Okay, and the simple way to do it, when the coefficient of x cube a here is positive number, well, the ending part points upwards. When it's a minus number, the ending part points downwards. Okay, that's a simple way to remember it. Okay, let's do simple examples here. For example, if I have y equals to 5x minus 1 and x plus 2 bracket times x plus 3. Okay, say if I have a function like this, let's find the x-intercept first. When x equals to 0 for y-intercept, y will be, we substitute this number in, will be 5 times 1, 5 times minus 1 times positive 2 times positive 3, which is minus 30. That's our y-intercept. So when y equals to 0, we will have 0 equals to 5 bracket x minus 1, x plus 2, and x minus 3. So our x value is 1, because 1 minus 1 gives 0, or minus 2 plus 2 is 0, or positive 3. Okay, because 3 minus 3 gives 0 in here. That's how do we solve this one. So we have 3 y-intercepts and we have 3 x-intercepts and 1 y-intercept. Let's sketch the graph. Okay. So from the equation we know the graph is this shape. Okay. Because the coefficient a is actually a positive number, so it has to be in this shape. So the 3 x-intercepts are minus 2, 1, and 3. That's our x and y. And the graph looks like this. Yep. And our y-intercept is that. Oh yeah, sorry, I did make a mistake. Our x-intercept is 1 minus 2. Copy down wrong equation here, and minus 3. Okay, because minus 3, well, when x is minus 3, minus 3 plus 3 is 0, so the whole thing is 0. Sorry, I made, yeah, I copied wrong equation, so minus 3 will be somewhere there. and our y-intercept is minus 30, which is here minus 30. Okay, now we can sketch the graph. The graph would be something like this. Okay, and our y-intercept is minus 30, and that's it. That's how do we sketch a graph. And the domain is x belongs to R. Okay, okay. And as you can see from the graph we sketched, there is a turning point here and a turning point here. Okay, and you don't have to find out the turning point for now, because you need to learn how to do differential equations to find the turning point of the graph, and you will be learning that in year 11 math method. And depending on the school, some schools start to teach differential equations or the rate of change in the beginning of the second term, and some school like to teach them in the beginning of the third term. It's really deep. Well, in year 11 math, it's really deep. When you're going to learn this, it's really depend on how your teacher structured the course. Okay, and so for the moment, what you have to know here, you only have to know there's a turning point, and in this part there is a local, we call it a local maximum turning point, because at the turning point here we have a local maximum number. Okay, it's local maximum because it is not the maximum of the graph. The maximum of the graph lays somewhere there, because as the domain increases, the graph keeps going on. Your maximum point on your graph should be somewhere there when x is infinitive and y is infinitive. So, but we have a turning point there. We call it the local maximum turning point. Similarly, in the turning point there, we call it the local minimum turning point. Okay, same reason it is local, because this turning point is not a minimum point of the graph. The minimum point of the graph lays somewhere there. When x decreases to minus infinity, your y value should be minus infinity, and somewhere there is your minimum point on graph. But because we have a curve shape there, we have a turning point, and we call it the local minimum turning point. Okay. This is what you have to know. Local maximum, local minimum turning point. Okay, and yeah. Overall, I do a summary. Overall, you have to know the shape of a cubic function is whether this shape or this shape. Okay, it is this shape when you have y equals to a x plus a number cube and plus another number. You sketch this kind of graph by finding the point of inflection first. Okay, and or you will have a graph in this form: a equals to x plus a number, x plus another number, also x plus another number there, and you sketch the graph will be this shape, and you sketch it by finding the x intercept and y intercepts first. Okay, and if there's a minus sign in the front, and your graph would look like something there. If a is less than 0, and when a is less than 0, in this form your graph would look like that. This is everything you have to remember. Okay, also local turning point, and you have to, if you sketch a graph like this, you have to know the local maximum turning point or the local minimum turning point. Okay, now let's do some example questions.